coolest, most exciting thing ever. Called addition, subtraction of vectors. Vectors are cool, but the presentation today will see what that goes. Addition and subtraction of vectors. Okay, we're going to start with vector addition. Okay, we're going to say consider two vectors A and B. When vectors are added, they are added tip to tail. And the resultant is A plus B. I'll get out of the way here for those who can't see. Okay, I'm going to do the next. I'm going to call it the triangle method of adding vectors. I'm going to take a break here so everyone can see once I draw the diagram. Bless you. Okay, so here's vector A, like this. Here's vector B. This on the top is A plus B. I'm going to explain this a little bit for those who haven't done physics yet. Now, what I'm saying when it says added tip to tail, it says the idea is you're going to start at A, you're going to point it down in this direction, vector B then is going to be touching, you okay? That's right. Number B is going to be touching the arrow of this one going up, and the resultant goes from the start of the first vector to the end of the second vector. Okay? Now, I'm going to let people copy for a sec, so I want to make sure the non-physicists in here get that concept, because that is sort of what we're talking about today. Okay, so you're going to start at the one vector, and again, vectors are movable, right? And this is the nice thing about technology. I can hopefully move this right now. If B happened to be like this, you can move it wherever you want, right? So you can move it, and that's how it has to be when adding. Like B could be like this. You see what I'm saying? This is my technology demonstration. You can move the vector wherever you want. That goes over. So we're good. I know the physics people are bored out of their minds. But stay with me here, please. Okay. We're also going to say the parallelogram method. I will not use this method, but you may if you want to. All right, Caleb. When I look at that right there, why is that not making me happy?
Is it because they're both like the tails?
Yeah, right on. Okay. So what would I have to do in order to add those? Somebody help me. Is anybody here? What do I have to do to add those two? Right, Chris?
You just kind of like move the B over to the left side of the A.
Yeah, you can. So, very good. So what I'm going to do is I'm going to just move B up. Now I'm going to actually draw it like this, okay? Because that's an equivalent vector to B, like that. So everyone see that? And if you take a look at this one over here, would be equivalent to A. So the idea is that's the parallelogram that they're saying. So the resultant would go from A to B, like what Chris said. And then there's A plus B. Now, I don't like that method, okay? I prefer, the idea is you can, what I would just do is I just erase this vector to give and move it up, but you can treat it like that to do it add it like a parallelogram as well. Okay, are we okay on the idea for that? Again, I will not use the second method, but for those that are physicists, you may have seen that before, you may use it. Here we go, subtracting vectors. This is fast. We're going to say from Friday. The opposite vector has what? Teresa, I'm going to let you use your memory or your notes. What is an opposite vector? Remember we talked about that from Friday?
Is it like the opposite of equivalent?
Yes. I need more mathy words though. It is the opposite of the equivalent. I need more mathy words though. Go ahead.
It has the same magnitude and size, but is going in the opposite direction.
Right on. Okay, so it has, so again, remember if we're going 200 miles an hour this way, the opposite vector would just be the same thing 200 miles this way, okay? So where the opposite vector has the same magnitude, and opposite direction. So we're going to say to add u plus u minus v, whoops, to subtract u minus v, we change it So what we're going to do is we're going to still, when we subtract two vectors, we're going to add them, but we're going to add the opposite of the second one, if that makes sense. Okay, so that's how you're going to subtract vectors. So let me just write what that says here. So we're going to change the direction. Like I said, this is a totally exciting lesson. Of v, and then add it in the previous examples. Okay. Is this sort of logically making sense? I'll get to the examples at the end. I want to get all these notes out of the way. Else, this is sort of making sense. Okay. We'll get to triangles in a few minutes. Okay. And we got a second to scribble. We'll all mostly scribble. That's the last few words. Okay, so here we go. Opposite vectors and the zero vector. Okay, so let's say I do 3 plus negative 3. So you're going to get this difficult math question. What is 3 plus negative 3, please? 0. 0, good. Okay. We're going to define, oops. In the same way, we're going to say that u plus negative u is equal to the 0 vector. Okay. The 0 vector has no magnitude and no direction. You can't say it's 0 newtons up because it doesn't make sense. There's no direction, right? Just 0 newtons to 0 newtons. Okay. Now you might, some physicists may say to me, Mr. Sabat, how can it be a vector if it has no direction? Well, it is. Okay, I'm just going to leave it at that, okay? It's called the 0 vector, we'll call that. in the same way, using my math, unless I have it on the next page, no I don't. Does somebody want to take a stab at this one? If I have a vector u and I add a 0 vector to it, what do I end up with? Yeah, that, just a u vector, right? I'm not trying to be tricky here, I just want to go through some of this basic stuff there. Okay, I'm going to hit a pause so you guys can catch your breath from all this note taking. Okay, and then again, I wish there were more examples. I got 2 more things here, and then we'll call it a day here. Okay, for 2 more notes, and then we'll get to some word problems.